Hello, welcome back. In this section, we're going to learn about classifying matter. So what are the different groups that we can put matter into and actually what matter is. So matter is defined as anything that has mass and takes up space. So anything we see around us is considered matter. It's actually easier to define things that are not matter than things that are matter because most of the things we know of are actually considered matter. So, for example, air, water, people, animals, those are all considered matter. A few examples of what is not considered matter is light, gravity, energy, right? Notice those are not things that take up any space. So basically, in order for something to be considered matter, it has to be made up of atoms and molecules. So matter can be categorized into two different groups, pure substances and mixtures. Pure substances contain only one type of substance. So what you notice in each of these four containers is that every single particle that's contained in that container resembles the other ones. So in this container, every single one of these are red balls, for example, or red particles. In this container, every single unit is made up of two green particles stuck together, right? This one looks the same as this and looks the same as that. In this container, they're made up of two different particles, but every single one of these units resembles another one. So each unit contains a blue and a pink particle stuck together. And likewise in this container as well, we can see that both of these units resemble each other. Now, mixtures contain two or more types of substances. So basically, if I take two different pure substances and mix them together, that gives me mixtures. So notice here, this container has both the ones that are two green particles stuck together, as well as the one that has a pink and blue particle stuck together. So it's not all one type of substance. There's more than one type of substance in here. Likewise in here as well. So some examples of mixtures are like lemonade and seawater, right? In lemonade, we have sugar, we have water, we have lemon. In seawater, we have water, we have salt. So they're made up of two different types of substances. Now we can actually classify pure substances and mixtures into different groups as well. So pure substances can be categorized into elements and compounds. Elements are made up of one type of atom. So these two containers here are both considered elements. The reason they're considered elements is if you notice, inside of each container, there's only one type of atom. So if we assume each one of these is an atom, each one of these balls is an atom, then inside of this container, every single one of them is a red atom. Inside of this container, every single substance is made up of the green atoms, the same two green atoms stuck together. So there's a difference between these two containers in that in this first container, each of them is a single atom, each unit is a single atom. Whereas in this container over here, each unit is two green atoms stuck together. But still inside of each of these containers, there's only one type of atom, and that's what makes it an element. A compound, on the other hand, is made up of two or more types of atoms. So what you notice is that each of these units, even though they're still the same, each unit looks the same as all the other units, right? That's what makes it a pure substance. Within each unit, there is two different types of atoms. There is a blue atom in this case and a pink atom stuck together. So because there's two different types of atoms, this is considered a compound. Likewise here as well, we see that there is the repeating purple, yellow in each one of these substances, but each unit looks just like the other unit, so it's considered a pure substance. But it's a compound because each unit is made up of different types of atoms. Mixtures can also be categorized into different groups. They can be categorized into either heterogeneous mixtures or homogeneous mixtures. Heterogeneous mixtures consist of two or more phases. So what you see here in this container is that there's two phases, right? This green seems to settle to the bottom, right? The particles containing the two green balls settle to the bottom, and the one that's a blue and a pink is more towards the top. So heterogeneous mixtures are not uniform throughout. They contain two phases. An example of a heterogeneous mixture is sand and water. The sand settles to the bottom while the water stays on top. And you know that the prefix hetero means different, and so that's referring to the different composition. Homogeneous mixtures, on the other hand, are uniform composition throughout. The prefix homo means the same, same for same uniformity. So notice here, you can kind of tell that the particles or the substances are spread evenly throughout. So the red ones are spread evenly throughout, and so are the ones that are made up of the blue and the pink balls. An example of a mixture is salt dissolved in water. When salt is dissolved in water, it's homogeneous throughout, or homogeneous throughout, it's uniform throughout, and you can't really see the salt particles because they're dissolved in there. Another example or another word for a homogeneous mixture is solution. Okay, so the word solution doesn't necessarily have to be used for a liquid. It can be used for solid, liquid, or gas. So here is an example of the two different types of mixtures we looked at. Homogeneous mixtures are uniform throughout. So when I dissolve sugar in water, I get a homogeneous mixture. Notice that a spoonful from the top is the same as a spoonful from the bottom. So it's uniform throughout. Whereas in a heterogeneous mixture, we get two separate different phases. So when I put sand in water, for example, the sand goes down to the bottom, sinks down to the bottom, and the water stays on top. So in this case, a spoonful from the top is different composition than a spoonful from the bottom. So that's a heterogeneous mixture. Now, elements and compounds can actually also be classified into different categories as well. An element can be classified as an atom or a molecule. If it's an atom, each unit is made up of a single atom. So notice each of these little red balls is an atom, and notice that each unit is one single atom. We call this an atomic element. It's an element because it's just one type, and it's an atom because it's a single one of one type. Here we have a molecule that's an element, and this type of molecule that's an element is made up of the same type of element, same element, that's what makes it an element, but it's a molecule because there's two or more atoms, and actually in this case, as we're going to learn later on, they're non-metallic atoms that are bonded together, that are attached to each other. So at least two have to be attached together to make it a molecule. It's an element because these are all the same type of atoms. As opposed to this type of molecule that's a compound, we call this a molecular compound. It's also a molecule because there's two or more atoms bonded together, but since these atoms are made up of different elements from different elements, this is a compound. And then we have ionic compounds that are actually form a lattice structure. And what a lattice structure is just a repeating unit, in this case, of positive and negative charges. So you can think of the purples as being positive charges and the yellow as being negative charges, and they alternate. We're going to learn later on that these positive charges are usually metals and the negative charges are nonmetals. So now what we're going to look at is basic unit. The basic unit is the simplest unit of a pure substance. Basic units can only be applied to pure substances. So they can only be applied to atomic elements, molecular compounds, and ionic compounds. So basically they can be applied to elements and compounds. Atomic elements have as their basic unit an atom, because notice each one of these units that makes up the structure is just a single atom. Molecular elements as their basic unit, so one of these is its basic unit, and that's a molecule because it's made up of two or more nonmetallic elements. And that's the same for a molecular compound. Its basic unit is a molecule, right? One of these units is a molecule. For an ionic compound, because it's made up of repeating positive and negative charges, its basic unit is the smallest whole number ratio. So its basic unit is called a formula unit. In this case, the basic unit is a positive and a negative, and we call that a formula unit. Next, we're going to look at hydrates. In hydrates, the water molecules are actually part of the compound. So the way to recognize hydrates is that they have this dot and then some number of H2O attached to an ionic compound. So here the XY represents an ionic compound. So for example, copper sulfate pentahydrate, that's how we name it, is an ionic compound that is a hydrate. These water molecules are actually part of this structure. A lot of students mistake this for a mixture because they think that these water molecules or the copper sulfate is dissolved in the water molecules. That is not true. In the case of hydrates, the water molecules are actually part of the entire compound. They're not part of a mixture. It's actually part of this compound. And so hydrates are pure substances and they're ionic compounds because they contain a metal in them. Right, so now we're just going to review some of the terms that we've already talked about in this section, just kind of to reiterate what we've learned. So elements are made up of the same type of atom, right? Elements can either be these atoms or they can be molecules, okay? But it's just one type. Molecules are made up of two or more non-metallic atoms. So we're going to learn later on what elements on the periodic table are considered metallic and which ones are considered non-metallic. But just keep in mind for now that the definition of a molecule is two or more non-metallic atoms. Basically, there cannot be a metal in molecules. Those two atoms that they're made up of can either be the same element or they can be different elements, like we see here. So this one is a compound, and this one here is an element. Compounds are made up of two or more different elements. The key word for compounds is different. The key word for molecules is non-metallic, so no metals in them. So some molecules are some molecules are compounds, right? If they're made up of two different types of elements, and some compounds are molecules, okay? But compounds can be made up of the same element or different elements, and compounds can actually have metal in them, so be made up of metals and nonmetals or just non-metallic elements. It doesn't matter. They're not like molecules where it has to be specifically non-metallic. Solution is another word for a homogeneous mixture. If there is water in this solution as the major component, we call this an aqueous solution. So in an aqueous solution, a substance is dissolved in water. And we symbolize that by writing parentheses AQ, parentheses, after the substance that is dissolved in water. That indicates a homogeneous mixture where the substance is dissolved in water. And then hydrates we just talked about are ionic compounds where the water molecules are actually chemically bonded to the ionic compound. And then we talked about basic unit. We said basic units are the simplest units of a pure substance. The three words that we can use for basic units are either atoms, molecules, or formula units. And keep in mind that basic units cannot be applied to mixtures. They can only be applied to pure substances. And then one other thing to remember that we talked about is that the words compound, element, a molecule, those cannot be applied to mixtures. Those can only be applied to pure substances. So the only terms that can be applied to mixtures are either heterogeneous or homogeneous. That's it. No other terms can be applied to those. Right, so here are a few problems for you to solve. So you can just click pause, try these problems, and then on the next slide, look at the answer. And here are the answers to the practice problem.